So previously we already learned about differential rate equation. So if we consider this equation, so rate of reaction is equal with 1 over 2 rate disappearance of reactant equal with rate appearance of product. So differential rate equation will connect between rate disappearance of reactant with rate formation of product, and it will consider stoichiometric coefficient. Okay, next we will learn about rate law, also known as rate equation. So in rate law, the equation will relate between rate constant, concentration of reactants only, and order of reaction. If we consider this equation, A react with B to produce C and D. So rate of reaction is directly proportional with concentration of reactant only. So if we remove the proportionality sign with equal, then we will have a constant, and this constant known as rate constant. So we can see the difference between rate law and differential rate equation. Rate law only consider reactant. Rate law won't consider stoichiometric coefficient. Rate law dia tak akan ambil kira stoichiometric coefficient. Okay, next we talk about rate constant. So larger value of K, faster the reaction proceed. And then K does have unit. K ni ada unit. Tapi unit dia tak ada yang spesifik. The unit must be derived from rate law. Dia ada unit tapi dia tak spesifik. It's depending on your rate law. Okay. And then kalau kita tengok kat dalam equation rate law, kita ada to the power of x and to the power of y. So what is x, what is y? X and y is actually order of reaction. Okay, so value of x and y can only be determined by experimentally. Okay, so order of reaction is not related to the stoichiometric coefficient. So this value must be calculated from experimental data. Okay, so the value of order of reaction can be in positive integer, but normally order of reaction is 0, first order, second order. This is the normal value of order of reaction. Okay, here is an example of rate law. Okay, so we can see that for fluorine, it is first order reaction, and for ClO2 is a first order reaction. So this value is not related to the stoichiometric coefficient. Actually, you need to calculate this one according to experimental data. Just untuk fluorine ni, accidentally dia tersama. Accidentally tersama boleh. Tapi bukannya kita ambil daripada stoichiometric coefficient. Sebenarnya kita kena kira daripada experimental data. So next we will look at on how to determine order of reaction based on experimental data. Okay, second method to determine order of reaction is change of rate of reaction when concentration of reactant is changed. So we will look at effect on rate of reaction when we change concentration of reactant. So for this rate law, we do not know the order of reaction yet. Okay, so if we increase concentration of A by any amount, increase concentration of A by any amount means we double concentration of A, we triple concentration of A. What happened to the rate of reaction? The rate of reaction remain unchanged. So we increase concentration of A by any amount. Sama ada kita doublekan ke, kita triplekan ke concentration of A, tapi rate of reaction dia tidak berubah. So actually dia adalah zero order reaction. Okay, so if we increase concentration of A 2 times, increase concentration of A by factor of 2. Maksudnya kita doublekan. Increase by factor of 2, maksudnya kita doublekan concentration A. So apa berlaku dengan rate? Rate pun double. Kita increase concentration of A by factor of 3. Maksudnya kita increase concentration of A triple, 3 kali ganda. Rate pun increase 3 kali ganda. Kalau dia follow, concentration berubah, rate tu follow, concentration double, rate pun increase double. Concentration triple, rate pun increase triple. So actually dia adalah first order. Okay. Last one, katakanlah kita increasekan concentration A double by factor of 2, tapi rate increase by factor of 4. Kalau kita increase concentration A by factor of 3, rate increase by factor of 9. 9 kali ganda meningkat. So actually dia adalah second order reaction. So apa formula dia? Formula dia adalah X squared. So kalau increase by factor of 2, so 2 to the power of 2. Increase by factor of 3, 3 to the power of 2. Increase by factor of 4, 4 to the power of 2. Maksudnya rate akan increase 16 times. Okay, next kita akan tengok example. So the reaction of A with B will produce a product was found to have rate law. Rate is equal with K, concentration A, so A is first order, concentration B is second order. Predict by what factor the rate of reaction will increase when concentration B is double and concentration of A remain unchanged. So B sekarang kita double kan? So apa berlaku dengan rate of reaction? Concentration A tidak berubah. So kita tahu B adalah second order. So kalau kita double kan concentration B, so rate akan increase by factor of 4. So jawapan dia 4 lah. Ataupun increase by factor of 4. Okay, kita tengok next example. Given rate law, by which factor does rate increase if each of the following changes occurs? Okay, so the first one, concentration NO2 triple. So kita tahu bahawa NO2 ni ada second order reaction. So apa berlaku dengan rate? Rate akan increase by what factor? So kalau dia adalah second order, and then concentration NO2 ni triple, maksudnya factor 3, increase by factor of 3. So 3 to the power of 2 means 9. So the answer is 9. Okay, so for the second one, NO2 and Cl2 both double. So dua-dua kita increasekan double. Dua-dua concentrationnya jadi 2 kali ganda. Okay, untuk second part, kita tengok one by one. So kalau NO2 ni dia adalah second order, so bila kita doublekan NO2 ni, rate akan increase 4 kali ganda sebab 2 kuasa 2. Okay, kalau kita increasekan concentration Cl2, so Cl2 dia adalah first order. So bila kita double, rate akan increase pun double. So kita kena multiply. Efek dia ni kita kena multiply. So 4 darabkan dengan 2, so rate akan increase by factor of 8. Okay, third method nak determine order of reaction is by looking at unit of K, unit of rate constant. K does have unit but the unit is not specific. Okay, so consider a reaction with only one reactant which is A. Okay, katakanlah A ni dia adalah zero order reaction. So rate law dia adalah rate sama juga dengan K, concentration of A to the power of 0. Anything to the power of 0 is equal to 1. Okay, so unit of K ni sama dengan rate lah. Rate unit dia adalah molar per second. So unit K adalah molar per second. Untuk zero order reaction, so unit K dia adalah molar per second. Okay, katakanlah dia adalah first order. Okay, dia adalah first order. So unit of K adalah rate bahagikan juga dengan concentration. So rate unit dia adalah MS negatif 1. So concentration unit dia adalah molar lah. So kita cancel. Dapatlah unit K untuk first order reaction which is per second. Okay, katakanlah kita consider A ni adalah second order reaction. So K ni sama juga dengan unit rate. MS negatif 1 dividkan juga dengan concentration sekarang to the power of 2. So, molar kuasa 2. So, kita cancel. So, kita akan dapat unit K. Molar negatif 1, S negatif 1. So, different order, different unit of K.